All right. Hello, at-home students here. Just want to show my face real quick here and say hello. Hopefully you guys are doing well. We are going towards the end of chapter 2. So hopefully you are keeping up with the videos here, and I send out an email sort of update. Please email me back in regards to how you're doing in the class and you're getting stuck in any homework assignments. Want you guys to be prepared for the exam as we will start it, or be prepared for the exam for next week. All right, class, let's go with it here. This is, 2.6 homework, right? 2.6 homework that's given. So let's go 35, then we go 39, 59, Dylan, is that right? 59?
Yeah.
It's 73.
73.
Sure. Let's jam. I'm so glad. I'm so glad
I have
there's
a
not.
question about showing work.
Go ahead.
On a lot of these, it was like just for finding the vertical and horizontal asymptote, do I have to show my work for that too? Or just like, because when it had like the polynomials and then the equations with like the cube roots, I showed my work like simplifying those down. But then do I need to show my work for when it's just like finding x-intercept and just like to answer one?
No, so if you just say VA is x equals 3, that's fine. If it's obvious. I figure this, if I have to show my work for it, then I have to think things through. If I can't do it in my head, I assume you guys can do it in yours, sort of thing. Unless you're brighter than me, then you should be the teacher. But
I'll be the teacher.
oh, never mind.
I'm such a good teacher. Only in math class though. I have to help you. Okay, but that's because I can't laugh. Yes.
All right, let's go with it here. So first things first.
Because I have more fun.
Let's go through it quickly as we get to 2.7 here. So state the domain of the function first. What's the domain? Is there ever a time that the bottom is going to give you a 0?
Is that a 5 or an x?
That's an S. That's the question. Is that a 5 or an S?
No, because it's +1.
Yeah, this little +1 here. So if you were to start trying to solve it for, let's kind of go the long way here. So if you're trying to solve this for S and you subtracted 1 from it and you took the square root, you get yourself that little square root of a negative. Once you take a square root of a negative, it does not belong on a graph. We're good? It's not on a real number graph. And then if you try to factor it, you can't, right? Because that's not a factorable form. You can't have the sum of 2 squares. There's only a difference of 2 squares. We're good? So there it is. So domain then, there's no cracks in our graph. There's no breaks in our graph. So the domain is from -infinity to +infinity. That's one way to say it. Another way to say it is all real numbers. And I think your book does it this way.
So I looked in the back and it said all real numbers except s.
I think all real numbers S.
All real numbers S, maybe.
Oh, that makes sense. I don't know.
B, identify all intercepts. So we've got to do both of them. Identify all intercepts. So let's start off with the y-intercept first, because that's the easiest one to do. You just plug in 0 in for all the s's. In this case, it becomes this. And because that is 0, you can kind of just list it on the side here, 0, 0. You know, if it's 0, 0, you know x is also an intercept, right?
But then to find the x-intercept, you just use the top.
X-intercept, it's just going to be the numerator only. Set it up and it's already solved. And you get the same exact answer. So there it is. It goes through 0, 0. We know that. Stating the vertical and horizontal asymptotes. So the VA, vertical, let's go with that one here first. Vertical is any breaks in our domain, right, that are not, that are in lowest terms, right? There was no way to factor this in the first place. So in this case, none. There should not be any vertical asymptotes here. Horizontal asymptotes. Let's talk about this guy. Degree on top. What's the highest exponent on top?
1.
It's a 1. Highest exponent on the bottom? 2. It's a 1/2. Therefore, y equals 0 is the horizontal asymptote. We good? If it was 2 and 2, we would take the ratio, right? If it was 3 and 2, we know it was a slant asymptote, not a horizontal. And anything different from that, we will not know. Okay, and then D is the next one. Plot additional solutions if you need it, and then sketch the graph. So I think we got it. Let's see. I'm gonna try to do it up here just so we can do it on the same slide. The dot that I know goes through is this guy here. Oh, look at that. That's so funny again. Look at this. Our graph actually goes through the horizontal asymptote. So boom, there's my horizontal asymptote. There's my dot. And there's never a time that this guy is going to have a vertical asymptote. Once you get a vertical asymptote, it's a lot easier, right? We've seen those on the homework here. No vertical isotopes here. So I guess we need some more points here. Let's see what this looks like here. And so if you're stuck and you're totally stuck, you got to go back to our algebra stuff, algebra 1 stuff with tables. So I got S and then I got G of S. And we go from there. So easy ones to put in maybe, like I'm going to go like -2, -1. We already know what 0 is. So 1, 2, and then maybe 3. Let's see what happens with 3. We'll see where we're at. So -2 plugged in. What do we get here? -2/5. Okay. -1 plugged in. Is it 1/2? Yeah. 1/2, +1. Let's see if they're symmetric. I want to see if they're actually symmetric or not. Let's see.
1/2.
Oh, that is so cool. Okay, so notice the plugging in negative value is the same thing as plugging in a positive value, but the opposite, right? It's the opposite of that one. Okay, so 2 plugging in a 2 most likely will give us 2/5. And plugging in a 3. 3/10. Wow, okay, so hold on. The -3 would also be 3/10. Let's do one more. Let's do 4. 4/17. Wow, that's tiny. Okay, so now let's go with it. 1/2. 2/5. Bigger or higher than 1/2?
Yeah.
Smaller, huh?
Yeah.
So I go out maybe 1, 2, 3, 4. 1, 2, 3. Let me go out 4. Yeah, this is the unusual one. This is the one you're supposed to at least struggle with a little bit here. So I got, if this is 1 here, that's 1. I'm going to make these 1 and -1 here. So 1/2 would be about right there. 2/5 would be just tiny bit lower, right? 3/10. Now that's almost like a third lower. 4/17. That's almost like a quarter because 4/16 would be a quarter. So then we have that right there. Going back the other way, we know it's going to be exactly the same because we already saw it here. So 1/2. Oh, sorry, it goes the other way, right? It goes this way. It goes -1/2, -2/5, -3/10, -4/17. Huh. And then it has to hug the horizontal asymptote at the end. So it can't be on top, has to be on the bottom. So I got a graph that goes like this. Comes up like that. Nah, that's even too fast of a, comes up too fast. It'd probably be like more like this right here. It comes like this. And then it turns to go through this, it has a little high value, and then it goes down like that. Something we didn't cover on the notes here, because on the notes, we never had one that did not have a vertical asymptote, huh? Sorry, that was my fault. We should have at least done one that did not have a vertical asymptote. Okay, here we go with 35 now, though. So this one, yes, this one we had to go back to our knowledge of algebra 1 with tables here. I hope that's not going to happen again. Let's see.
Will something like that show up on the test?
Let me think about it. Ask me again on Monday here as I finalize the test stuff. 39 is the next one. 39, whoa. Okay, this one definitely needs some factoring here. 2x to the 5th minus 5x minus 3. This is x cubed. Oh, wow. Okay, so maybe off to the side. I got to get this into factored form. So let me do that first here. Let's think upon this guy. Can we factor this guy down? Let's see. The only way to get a 2x squared is a 2x times x. True? Because those are prime numbers. I like guessing with prime numbers because it's one or that number. So now the question is, how do I get -3 as a product in the back so that my middles will give me a -5? Plus 1 right here. Charlie says -3 here. And let's check. Let's check if Charlie's right. -6x, 1x, and that will add up to -5. Perfect. Thank you. So we got this factored form. That, okay, now we're gonna do the bottom as well here. This one has 4 terms. Oh, do you guys know, do you guys remember that little 4-term stuff with factoring? Something called, long time ago, grouping method. Remember that grouping method? It's when you have 4 terms. Man, that's all the way from like September, isn't it?
Yeah.
Remember we did that when we were still online? We were doing the Appendix A. Remember that Appendix A factoring stuff? So I get to pick on people here. Isabel, give me what is the greatest factor out of the first parentheses? X squared will work. It leaves us with x minus 2. Okay. Annette, what can we pull out of the second parenthesis so that it matches the first parenthesis?
A -1.
Perfect. Yeah, -1 or -1. That'll switch the sign here. That'll switch the sign here. That's all I care about because now I have these 2 parentheses exactly the same. Now I'm going to pull out the parentheses themselves. So I'm factoring out x minus 2 out of this one. It goes in front. And the leftovers would be x squared minus 1. Ha ha ha. That I know to be x plus 1, x minus 1. It's a difference of 2 squares. Bring it up here. Sure. Hey. Did P over Q on this one? Okay. Absolutely. Yeah. In fact, we would do that if it did not fall nicely into the grouping method. That's what we'd have to go with. But either way, it's all the same stuff, right? You're still going to get the same answers. Camille, does anything cancel?
Can you pull out for on top, can you pull out a 2 for the x plus 1 and then that?
Ah, true. Here. No, the only way you can do it is if this was actually a 2 as well. They have to be common factors to pull out.
Then no.
Then no. Awesome. Okay, so then let's do this here. Can we, Camille, you get the domain answer. All real numbers except what? It's all the ones that are going to cause zeros inside here.
Is that a 2 or a 3?
This guy is a 2 right here.
So then 2. I'm sorry, what are the next 2 parentheses?
X plus 1. X minus 1.
I can't read it, and I'm sitting right here.
I'm fine. So then it's gonna be -1 and then +1.
Perfect. Gotcha. Okay, Landon, your tough job. If I start off at negative infinity, which one am I going to hit first in order to get out? So where's my breaks?
The first break would be -1.
-1. Perfect. So from da to net, and we put this a guy for a union usually. Union. And move on to the next one. From -1 up to
Up to
+1. Break again. You could put commas or U values. From positive
+1 to +2.
2. See it.
+2 to positive infinity.
Thank you so much. That's perfect. We're good. We have 3 breaks on our hands here. We have 3 because it didn't factor top and bottom. Nothing canceled. So we also have 3 vertical asymptotes on our hands. Whew, let's see how that works. Okay, let me go back to my little guide. Okay, the domain, yes. Identify any intercepts. Oh, this will be fun. Y-intercept, easiest thing to do. Ready, guys? Go back to your original problem. Easiest. Plug in zeros for all the x's. What is the only thing left over? -3 on top, right? And a 2 on the bottom. So -3/2. Notice I'm not even showing any of the work for it because that's too easy. So I can do this here. Let me put 0, -3/2, or even better yet, 0, -1 and 1/2, because I'm eventually going to have to graph it. So I want to be able to put it into a mixed number. Okay, x-intercepts. X-intercepts, pretty easy as well. Dylan, talk to me. Give me the x-intercepts. Sorry, Dylan. And we're going to get to Dylan in just a bit here.
The x-intercepts, wouldn't you just 0 equals everything in the numerator?
So the numerators now.
1/2 and 3.
Ooh, careful there.
1/2 and. I feel like that's wrong. No.
-1/2. Yeah. That little one scoots over, gets you a negative, and when you divide by 2, it gets you a -1/2. This guy's easy, right? This guy's just x equals 3. So let's write these guys out. How about 3, 0, -1/2, 0. Boom, boom, boom. I have to go on to the next slide. Are we good there with B? Thank you, Dylan, for that. Yeah, those, whenever we get fractions, just like this one right here, if it says x -3, you know you're gonna get a +3 out of it, right? So if it's 2x + 1, you know you're gonna get a negative and then whatever the fraction is. Cool. Jamming. Looks like today was homework day.
For the y-intercepts, I get the -3/2, but then where do you get the -1?
Just converting it from improper fraction to mixed number.
Oh, okay. So, but would it, because the book had -3/2, so if I catch that, would that catch, it wouldn't y?
Oh, no, that's fine. As long as you know that when you're going to be graphing it, technically it's 1 1/2 negative. So as long as you know
It
that.
just helps when graphing.
Yeah. Whenever in algebra, whenever we get answers that are improper fractions and we don't need to graph it, automatically we leave it as improper because it's easier. If we do have to graph it, that's when we usually change it to a mixed number because we want to see where it's going to fall on the graph. Okay, C. C it is. Any vertical or horizontal asymptotes? Oh boy. VA. X is equal to. And I'm not sure if they separate them by commas or not here.
Can you take the domain? Can you take?
In this case, it is exactly the domain right here.
Because like for a lot of the problems, in this one, it was the vertical asymptote.
45 should had one where you had to cancel those.
Yeah, that one had just like a straight line.
Okay, x is equal to 2. And I'm not sure if they just do it like this as well. What do they say in the back of the book? It was like this, or they separate them out. Like they say x equals 2. Because yeah, they have to separate them out because they're individual lines. Because one is a vertical line, the other one's another vertical line, the other one's another vertical line. You technically should have them separated out because
X equals ±.
Yeah, I think in the back they had plus or minus.
that's cool, yeah.
to separate them out from the two. To show that they're different lines.
Yeah, because they're technically different lines, yeah. All right, sorry, going back and forth between here, a horizontal asymptote, going back over here. Go back to the original one. Degree 2 on top, degree 3 on the bottom. That's easy enough, boom. Whoa, it disappeared. Did the 2 disappear? It did, yeah, I erased it. That's what's happening, okay. Y is equal to 0, everybody good there. D, plot any additional points if you need it. So let's go ahead and graph this guy. So let me just see what I need here. 3 is the furthest it goes out. So 3, so I'm going to go out to about 4, maybe 5. Let's see how this works out. 1, 2, 3, 4. 5 is good. 1, 2, 3, 4, 5 is good. Okay, and let's go with it here. Let me change pin color. Vertical lines are at x equals 2.
Oh, this graph was so confusing.
X equals 1.
There was like 4 lines.
X equals negative. Is it
Yeah, it's -1, positive.
negative 1? There you go. Sorry, I was looking the other direction. Okay, boom, 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 boom. Horizontal asymptote
0.
comes across this way. On the graphs, whenever the horizontal asymptote is the x-axis, they don't ever show it. I'm not sure why, because you still need to show it here. Okay, anything else that I'm missing here? The only dot that I know is, or yeah, I do know a few dots, don't I?
3.
Yeah, we know 3 dots here. So 0 and -1 1/2. So this guy dot I know. All right, give me the other ones just real quick here. What's the other dots I know?
-1/2 and 0.
If we just got that one, just
No, that was.
That's for the x-axis.
There's x equals -1/2.
X equals -1/2. So it's this one here, right here,
And there's x equals 3.
and x equals 3. So this one here, right? Is that right? Is that what we got there? Okay, so let's go back real quickly here one last time. Let's go back over here. I got everything, making sure. I got that. Yep. Okay. So based upon this, and based upon the fact that these guys are all factors of 1, is that right? So we have something called split direction each time we have the asymptotes. So I'm just going to look over here, thinking about which one is actually going to make the cut. This one right here. This is what I need. Everything else is going to be based upon that graph right there. Are we good? That's the one that shows me what I have. Cool. So that means this guy has to go like this.
Why is that?
Because there has to be a split direction at x is equal to -1.
Wait, but if it was on the top, if it was what's it, quadrant 2, like going like this, then wouldn't there still be split directions just from the other side? Or does it always go from the top?
It goes where this guy ended, right? Because it has to go in this direction or this direction. Sorry, yeah, good.
Since the middle one's going up and down, if you had it going the other way, wouldn't there still be a split direction just the other side?
Yes, correct. Yeah. So let's see see what I'm asking. Tell me if this is what you're saying. If for some reason the graph went like this, then this graph would have went like this. Is that what you're saying?
But why is it always it's still on this way? Couldn't you have the same thing? Because aren't there arrows on both ends of the middle graph?
There's here and here.
It's direction, it's direction at,
Something that ends on one.
Oh, okay, ending.
Yeah, it's the ending value here. So this is going down to -infinity. That means this has to start with positive infinity. That's the split direction. Does that make sense?
Yeah.
Okay. So in this case, because the dots are a certain way, that means it had to have done this, had to have touched and gone through this point, touching onto this point, and then crossed down further. This guy has to go like this. And then split direction here, right? There's none factors that have a square next to it. So split direction, I know without even having any dots here whatsoever, it has to go like this. Boom. Again, split direction. Ooh, then it has an x-intercept. That is so interesting. Okay, so real quick here, it has to start here, correct? But then it has an x-intercept, and there's no asymptotes afterwards here. Isabel?
For the one in between, the line that goes in between the
Uh-huh.
two really close, what?
That's right.
We don't have
There's
an
no
x-intercept
x-intercept.
there?
There's no x-intercept here.
Is that what the graph looks like?
Bummer, can't be here, huh?
Do you need a point or something? Not that you can tell us where it goes.
Okay, I could have to. No x-intercept. It has to be like this right here though, right? I am actually a little stuck here. Anybody have a calculator that can graph it here? Let's do this here. My guess is gonna be this right here.
Yeah, but it was like, wait, so how do you know that there's a graph right there?
There has to be graphs everywhere because we have points that are being pushed into a graph,
So
right?
in between every vertical asymptote, there has to be some sort of graph.
Yeah, because there are points there that are being computed into a function. So my guess is this real quick here, but let's see. It goes up like this and then it turns back around and there's my horizontal asymptote on the way out. Is that the way?
How do we know that it goes like that?
Yeah, sure. Let me check. Isabel's checking the graph here.
No, that's what they have in the back of the book.
That's what they have in the back of the book.
Oh, okay, okay, perfect.
Like, how would you know to put it there?
Sure, let's do it. Let's do it together.
Oh, wait, it has no x-intercept, so it can't cross,
Oh, I
and
see.
it has to start up high there, so that's like the only option.
Oh, I see.
So it has to start up high, no x-intercepts, and then it has to turn back around and go back up.
Meaning this one down here has to start low.
Oh, this is after we get this one situated.
Yeah.
So because this is low, this has to start high, no x-intercepts. So it has to come down, then turn back around, go back up high.
Meaning the next one has to start low.
The next one has to start low, and then it has to go through the x-intercept. Whether it goes this, how high does it go? We don't know yet. We don't know if it goes like this and then comes back down, or we don't know if it just goes up like this and then just kind of barely goes up and then comes back down. Don't know, but that little bump is there and it flattens out.
This one was so easy.
Yeah.
Yeah.
That was a tough one, guys. Tristan?
They're gonna be one of these in the.
Not this complicated. I don't think I'll torture you with that one. I did want you guys to try it for the homework. It's a good try for homework. 45. Hey, did you have an issue with 45 or no?
No, yeah, I don't.
Okay, 45 should be a straight line, right? By the time it all ends, because like, oh, that just cancels. And you have a straight line.
I was like back in algebra 1.
Uh-huh. The only thing with that one is that t equals -1. There's like a little hole there, right? Did you guys notice the
There's no
hole?
denominator, right? T plus 1 like cancels out.
Let's do it. Okay, are we good with this one, guys?
Yeah.
This, okay, 45. Let's do this one real quick here because you do need to see it. So this is f of t squared -1 t plus 1. Da, 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 da. Okay, so then we go to factored form, right? So from here, we go here. We say to ourselves, oh, that's t plus 1, t minus 1 over t plus 1. And these guys are going to cancel. So at the end of the day, this just becomes t minus 1 with a little tiny exception. And here's where the exception is going to be. Good. So A, what's my domain? My domain, back to the original graph, is
Isn't it all real numbers except one?
Uh-huh.
All real numbers. There's no denominator. You have to go to the original.
original one. Got to go to the original one.
That's what it's that for.
That little guy right there. Uh-huh. Identify all the intercepts. So intercepts come from the factored form. T is equal to 1 is the only intercept. And then the y-intercept, that's right. So sorry, real quick here, I'll do the same work, but let me label it here. So x-intercept is t minus 1 is equal to 0. It's the simplified version, so we have 1, 0. Y-intercept is back to the original problem. C, find any vertical asymptotes. That comes from this guy here, so none. Any horizontal asymptotes.
Because the top one, no, it's one bigger though.
It's one bigger, yeah, but this one is saying, do you have any horizontal asymptotes only? Later on in the textbook, it says identify any slant asymptotes. That's 59. So for this one, there are no HAs either. And then D says, let's graph this guy.
Totally like other one.
And so notice that our factored form just became a linear equation right there. We have no vertical asymptotes, no horizontal asymptotes. We know this graph goes through 1, 0, and it goes through 0, -1. And we know we like this graph except for this little piece right here. So this little, the reduced form tells us how to graph it. As we get to -1, we have ourselves this little hole right there. And then we go the rest of the way. So maybe over here next to the VA, maybe after we calculate VA, we could write any holes that we have. Even though they want you to go back to your domain to make sure everything's set. Once you graph it, you go back to your domain. Do I have all my domain taken care of? Oh, I got this -1 issue. Let's make that a
Also
hole.
BT, right, not X.
Oh, thank you so much. Where did I write? Yeah, this one, T. Okay, guys, 10 more minutes. Yeah, hey, go ahead.
Oh, I tried to send it off, I'm not coming home tonight, but I finished it all today.
Yeah. That's fine. 45. Okay, let's jam. We got 10 minutes left. Let's finish up the homework here. Next one on the list for homework,
You were just saying,
73.
I rather just like, yeah.
I just thought, it's not too long.
Okay, let me do it like this here. 73. All right, we have to use a graphing utility. So this one is very similar like the last one that we did on the notes here. So let's see, this is what we have. It says that P can be equal to 0. It can't be 100. You can't get rid of all 100% of pollutants, because that means you'll need a super duper filter in order to do that. Okay. So, okay, using graphing utility, you're just gonna graph it. So real quick here, anybody graph this? I think I know what the graph's gonna look like here. This is gonna be 100 right over here. So when you graph this on a window, notice what your domain is this right here. Actually, let's see. Yeah, we can do that on a graphing utility here. Hold on, let me do it this way. Ding, ding. Let me go to here. Let me go to here. Yeah, that should be there. Oh. All right, let's do this together here. Those that are ready. You guys see that at least. Y equals, let's punch in our little problem here. This is 255x divided by 100 minus x. So that should be our, it's this little, it's right below mode. Okay, our problem is going to be our window. Notice our window goes from, our domain is structured between 0 to 100, right? And so we want to give a little bit more extra space than that. And so your screen, if you think about it, your screen likes to do about 20 across, right? Boom, boom. If it gets less than that, that's fine. So I'm going to go negative. Let's go to window, this little window setting right here. Let's click on that. I'm going to go from -10. I'm going to go to 110 because that will give me an extra little space in the sides. My little tick marks, the ones I want to do, I want to go every 10 on the tick marks. That'll give me 10. You can go every 5 on the tick marks. That'll be a kind of nice space for it as well. Yeah, actually, yeah, let's go every 5. That'd be kind of.
So when you get the tick marks, it's, what does it say?
X scale. X scale are your little tick marks. And I'm not sure how much it's going to cost, but you know, eventually as it gets to 100, it's going to go up, flying up like crazy, right? This is municipal in millions of dollars. So I'm going to go negative. I'm going to go -10. This one I'm probably going to go to 100 as well. Maybe 110 as well. There, scaled by 5s. X resolution, don't worry about that. That's kind of like the way the resizing of the window happens. There you go. Okay, are we good there? We're ready for graphing? You guys talk to me here. Those that have calculators, let's go. Whoa, that was way too fast. Whoa, hold on. Here's my 100, right? And then this guy went up to a lot already here, right? So that means my X scale in millions of dollars, I'm at 100. I was at 100 times a million. So I was at 100 million right over here.
Okay. Is it because it's being divided by the 100 minus 3?
Again, Benny?
Is it because it's being divided by the 100 minus 3? No.
This little guy right here, because the 100 minus P on the bottom, that's this line right here. Here's your vertical line right here. My issue is that little piece right there. Okay, so let's make our window bigger along the y-axis. So right here, y-max, let's make this 900. Let's see where we're at on that. At that point, it does not make sense. This be a 5, maybe every 10, even though it's going to look kind of really, really close together anyways. So let me finish up before time runs out here. Oh, that's a little bit better. Notice it's right here. It does get quite close over here, but this is at what, 900 million at this point? Is that right?
$900 million.
Uh-huh. Right there. Okay, are we good there as far as graphing? Let's jam to finding the answers. Is find the cost of removing 10%, 40%, 75%. This one's a cool one to do on the calculator because what you want to do is you want to go to this little calc menu right here. Second function, calc, and you're going to find out the value. What's my value at x equals 10? Love it. So about $28 million. And you can see where the dot is right over here as well. That little dot right at that little 0. Okay, we good there, guys? Let's go with the calc again. This is part A. So do I need to, let's talk to me here. Do we need to go back to here and write it out? So for part A, we graphed it. The graph sort of looks like this. It's at 100. And the graph, oh, let's see what happens below 0 here. It should be, we're going to start off like this. That's kind of the way the graph looks like. Boom. For part B at 10%, it's gonna be $28 million. Go back over here. Click the calc menu, boom, value at 40. 170. 40% give us 170 million. And this thing's gonna just go higher and higher very, very fast. So I need value at 75. 765 million.
That's a lot of money. Maddie, I need that kind of money. No, you don't, you're just gonna spend all of it. It's not useless stuff.
You spent like $1,100 on useless stuff this year.
It was 11,000, but. Okay. That's helping your case.
All right, we'll go with it here. It says, according to the model, would it be possible to get to 100%?
Yes,
The other answer.
no.
Good job, okay. So, can't get to 100% because it's an asymptote, right? And it'll be an infinite amount.
You can get to 99.9.
You can get to 99. And then with real filters on the block here, like I said, in my house, there's either got a water filter on the back end cover. It says 99.99%
Yep.
of most things because filters are there. And it's what, a $300 machine, right? So in that case, this is more going to be more like industrial municipal pollutants. This is the higher end stuff. I don't want to pay 765 million. Okay, we'll stop here. We did not get a 2.7 today, so we'll do that on Monday.
We don't know if it'll run like this, and I think right now it's set.
Correct, yeah, I'll have to change it. And have a good weekend, everybody.